Now this video is to talk a little bit more about angles and radians, and also to lead into a discussion about sines and cosines. So first, let me remind everyone what the definition of a radian is. Now, I'm going to draw a circle, and let's imagine that the circle is such that we put an angle inside the circle, drawing from the center of the circle out to the edge. Oh, I don't want that. Here's the angle right here. There's the angle of the circle. And it's customary to represent an angle using a Greek letter. We'll use the Greek letter theta right there. And the angle in radians is defined as the ratio. If the length of this arc here is L, the angle in radians, theta, is equal to L divided by R. Okay, so they call this the ratio L divided by R. This is the angle in radians. And if you think about, if we look at the angle of the entire circle, we go around the entire circle like that, okay? You know that the 2 pi R is equal to the circumference of the circle, call it C. So in that case, the arc length is the whole circle, the circumference of the circle, and the angle is then this arc length divided by R, or in other words, 2 pi is equal to this arc length, which is the circumference, divided by R. So the angle of the entire circle is 2 pi. And let me say this again and go back to our circle, that if we have a circle, okay, and we look at the arc length here subtended by the angle that goes all the way around the circle like this, okay, that arc length is the circumference of the circle. We know that 2 pi times the radius is equal to the circumference. So 2 pi times r is equal to the circumference. So if we take the arc length divided by r, c divided by r, we find that that's equal to 2 pi. So the angle that goes around the entire circle is 2 pi radians. So let's see where this discussion of angles and radians will take us here. Okay. We look at an angle here again. And I'm saying that the arc length subtended or covered by the angle, this length right in here, we'll say that arc length is is L. The radius is R. And the angle is theta. That the angle in radians, theta, is equal to L divided by R. There. So that's the angle. Now, if we drop the perpendicular from here down to here, we'll say this is line is as length y, and this line right here as length x. Here we still have r, except r now is the hypotenuse of this right triangle. As we're going to say, we drop the perpendicular so that that's a right triangle. We define the sine of the angle, sine theta, is equal to y divided by r. So sine of this angle theta is equal to this length, the opposite length of the opposite the side opposite the angle, divided by the hypotenuse. The cosine of theta is equal to the angle, the side adjacent to the angle, that in this case that's x, divided by r. Okay, now I have three expressions here. Okay, the first expression defines the angle in radians. Theta is equal to L divided by R. The sine of theta is equal to Y divided by R, the side opposite the angle divided by the hypotenuse of the right triangle. And the cosine of theta is equal to this X, the side adjacent to the angle, this side right here, divided by the radius. So cosine is this side divided by the radius, sine is this side divided by the radius. And the angle is given by this expression right here. So we have these three equations for the sine, the cosine, and the angle is expressed in radians. Okay, now this is pretty important stuff when you get to science and engineering. Knowing how to compute sines and cosines, in fact, is very important. If you're interested in music, music is represented using sines and cosines mathematically. So if you're using musical synthesizers, all of this sines and cosines appears in the equations used by the synthesizer to imitate the musical instruments. So that is a brief introduction into sines and cosines. Now let's look at let me get out of these expressions. So let's look at this expression right in here, this diagram, this drawing. Okay, here's what I've just said a few minutes ago, is that if we have a diagonal of length r shown here, and we have the angle theta, x is this distance, y is this distance. Now when we measure angles, it is customary to measure the positive angle as going in this direction. It's called, from this line up to this line, is called the counterclockwise direction. And we measure, if we measure an angle going from the x-axis down this way, the angle is in the clockwise direction, and the angle is typically referred to as being a negative angle. So positive angle goes in the counterclockwise direction, negative angle goes in the clockwise direction. So that's how we measure positive and negative angles. Notice that the sine of theta, remember, is equal to y divided by r. So sine of theta is y divided by r. Okay, cosine of theta is x divided by r. Say that again. If this distance right here is x, cosine of theta is x, that distance, divided by r. Okay, so if the sine of theta is y divided by r, then the sine of negative theta, the sine of this negative theta right here, is negative y divided by r, because the length of this line here is also r. And it's a lot to grasp here. Let me let me say it again and draw the diagram. Okay, if I have, here's the x-axis here, say, here's a y-axis going up and down like this. Okay, I have a diagonal R, and I draw my right triangle like this. So it say this point right in here is x, and this point right here on the y-axis, I'll call this point right here y. This is the angle theta. That the sine of theta is y divided by r, where r is the hypotenuse of the right triangle. And the cosine of theta is x divided by r. And this point, right, this distance here is x. Now, if we're measuring the angle in the negative direction, or the clockwise direction, this is negative theta. The cosine is still the projection on the x-axis. So the cosine of negative theta is still the same as the cosine of theta. Cosine of negative theta is x divided by r. But the sine of negative theta now is this projection, which is negative y. So we have the sine of negative theta is equal to negative y divided by r. So another way of saying the same result is that the sine of negative theta is negative the sine of theta. Okay, why is that true? Because sine of theta is y divided by r, and sine of negative theta is negative y divided by r. And cosine of negative theta is cosine of theta So cosine of negative theta is x divided by r, and cosine of theta is x divided by r. So these are the same, and these up here are negatives of each other. So that's it for sines and cosines at the moment.